This video, we're going to start to talk about inverse trig functions. Um, you may call them inverse sine, inverse cosine, and inverse tangent. I'm going to use arcsine, arctangent, and arccosine with the ARC in front of them just because that's the way that we usually write them out when we type them, because it's hard to get the inverse notation with a word processor and a keyboard unless you have something that has a formula insert with some symbols. So just know that those are equivalent, that saying ARCSIN of X is the same thing as saying inverse sine of X, like that. They're just two different notations for the same function. All of these things that we're going to talk about in this first section here are all going to be found on the unit circle. But before we jump to the unit circle, we have to know which quadrants in the unit circle we're allowed to look at for these answers. So when we're dealing with arcsine, we have to stay in quadrants 1 and 4 because our angle has to stay between negative pi over 2 down here and positive pi over 2 here, meaning we have to be coming from negative pi over 2, we need to be coming counterclockwise towards pi over 2 to stay in these two adjacent quadrants. Same thing for arctangent. It has the same restrictions as arcsine. That's why I wrote them next to each other. But arccosine is different because I can't use quadrants 1 and 4 because cosine is positive in both of those. I need a quadrant where the function, the original function, is positive and one where it's negative. So we're always using quadrant 1 for the positive piece. The adjacent quadrant to quadrant 1 where cosine is negative is quadrant 2. So those angles that are returned are going to be between 0 and pi. All right, so let's look now. The sine value is a positive √3/2. So I need to look in quadrant 1 for where the sine value is a positive √3/2. And that is 60 degrees or pi over 3. I'm going to answer everything in radians here because it doesn't tell me to answer in degrees. A positive √2/2 is going to be 45 degrees, which is pi over 4 radians. Now the cosine is negative √2/2, so I need to be in quadrant 2 and look for a cosine of negative √2/2. That's at 135 degrees, or 3 pi over 4. The tangent is -1. So if tangent is negative, I'm in quadrant 4. And I need to look for where the ratio of sine to cosine is -1. That's at 315 degrees, or 7 pi over 4. But I'm not allowed to answer that way. Remember, the tangent has to be between negative pi over 2 and pi over 2. So I actually need to answer this as negative pi over 4 because I went pi over 4 clockwise from 0 to get to this place on the unit circle. Now I want sine to have a value of 0.5, which is the same thing as 1/2. So that's right here at 30 degrees, or pi over 6. And last but not least, I want tangent to have a value of √3/3. That really is the same thing as 1 over √3. So I want my sine value to this is a tangent 1 over √3, like that. So this is my 30-degree angle here in my special right triangle. All of these things got divided by 2 in my unit circle, is why I don't easily see that ratio. But it is this one right here, 1 over √3 changes to √3/3. So this again is pi over 6. We're not going to look much at the graphs of sine, cosine, and arcsine, arccosine, and arctangent. I'm going to let you know, though, that the three most important inverse trig functions for you to know later in math are going to be arcsine, arctangent, and arcsecant. So even though your buttons on your calculator are for arcsine, arccosine, and arctangent, pay attention to the arcsecant function, because that's going to be one of the ones that you're going to use in calculus. Anything that can be expressed as arcsine can be expressed as arccosecant by taking the reciprocal of the thing that's on the inside and changing the function. Anything that can be expressed as arctangent can be expressed as arccotangent by taking the reciprocal of the argument on the inside and changing the function. And anything that can be expressed as arccosine can be expressed as arcsecant by taking the reciprocal of the argument that's on the inside. So that's it for this video. We'll come back next time and we'll talk about how this plays out with compositions of functions when we compose inverse functions. It's going to be slightly different than what we expected in the past, when we always had f of f inverse was x and f inverse of f was x. Now we have to consider these domains that and these restrictions that we put on these functions up here in this section. So we'll come back and talk about that next time.